So today with us, we have Thomas Jaeckle from Bionex.io. Thomas is a software engineer and currently working at Bionex to build the IoT foundation that they want to use for different use cases in real estate domain, where they want to connect different devices with the help of digital twins and Eclipse Ditto. Formerly, he was at Bosch to create a part of the Bosch IoT suite, which is concerning digital twins, was brought by the Eclipse IoT working group as Eclipse Ditto project. And Thomas is still the project lead and the main committer for it. And also previously at Bosch, he also participated in the WoT Thing working group, especially around the Thing models. And that is also the topic of today.
Yeah, welcome. So as Ege mentioned, it's mainly about using WoT Thing models, which we adopt in the housing sector and the real estate domain. And yeah, I want to talk a little bit about that. So some introducing words about Bionex.io. So we are in the real estate, in the housing sector. Our vision or mission is to digitize the real estate and the housing sector. We are quite young startup, so less than 3 years old. We are part of a bigger group, the Novantic group, which is in the real estate domain. And we're connecting different types of devices to our own, or mainly our own IoT backend. The headquarters is in Hamburg, Germany. However, our colleagues are spread all over Europe. So we are really an international small startup, I would say. So our world is we connect millions of private households in apartments. So it's mainly about apartments, and our customers are not the residents living in these apartments. Our customers are the housing companies and the landlords. So we have a B2B model. We do not directly have the residents as our customers. However, the residents use our devices as a service. So we come later to the device or the device types we support. One of these devices is a smart radiator thermostat, and the residents use them completely as a service. So they do not need to exchange the battery, they do not need to provide connectivity to the device, and also they do not install it by themselves or exchange it if it's broken. So that's a complete service. So historically, the group, the Novantic group, started more in the sub-metering domain. So that's the first main use case of our company as well. So to collect and allocate heat and water consumption, also electricity consumption of residents using different metering devices who send the data now electronically nowadays into some kind of cloud or into some kind of backend. In the middle, we have, for example, a gateway which collects this data via a specific protocol. And rather new device types which we also connect is smart heating devices. In this case, we see a smart radiator thermostat. I also have one on my desk here, so that looks very similar to the one on the screenshot. So that's really then targeted for the residents to give them control over how much heat they consume. So they can configure, for example, time schedules. They can remotely interact with the device using a mobile application to turn on the heating when they are on their way back to the apartment, so that the apartment is warm when they get back. That's a screenshot of the app, and the app is for the residents, downloadable via App Store, Android and iOS App Store. The different device types are also quite differently connected. So the metering devices are traditionally connected via MBus. That's short for meter bus. It's a European standard for remote reading of water, gas, or electricity. And these are typically unidirectional. So the devices send the current consumption periodically to some gateways, which are mounted in the house, and the gateways then send the measurings to a backend via internet. The rather new protocol we are supporting and using is LoRaWAN, and that's a technology using a license-free radio frequency to connect many devices with only a few gateways in the house over a long-range network. Long-range wide area network is the abbreviation for LoRaWAN, and it aims for low power consumption of the end devices, so that typical device such like this could last several years on a single battery, because, as I mentioned, the residents are not responsible for exchanging the battery, but an installer would have to exchange battery, and that's of course very expensive. And LoRaWAN is capable of doing bidirectional communication. However, the devices are not all the time online. So our devices are most of the time offline to save battery, and that means also, of course, I cannot just call an API of the device and get the current measuring from it, because like 90 or 95% of the time it is not available. It is offline, saving battery. So these are quite special devices, I would say, and a little bit challenging to interact with, of course. And of course, also the environment, especially in the housing sector, is important here. So in which apartment are devices installed, in which building, so where are they installed, and also to which customer. So here in that case, to which housing company or to which landlord do the devices belong? So who is the owner of the devices? But also, of course, who is the current resident of an apartment allowed to control the devices, and what happens if the resident moves out and another one moves in, so that the permissions of controlling the thermostats in an apartment is then also passed to the next resident. That's also, of course, important in our use cases. So that leads us to the digital twin chapter, more than just a buzzword. So we really have special challenges to solve. As I just mentioned, we have really heterogeneous device types. Our devices are mostly offline, and we have very different user groups. We have the residents using the apps for using the devices. We have installers installing the devices in the residents' apartments, but we also have operators, grid operators, who manage the grid of all of these smart devices and also sub-metering devices in the backend, making sure that when devices are broken or when batteries are depleted, that those are exchanged. And we also have multiple development teams, which either connect their device types. So we have different teams for different device types, making sure that, for example, the smart radiator thermostat is connected to the cloud, and that messages from the device are translated into an abstraction, and that also messages can be sent to the device. But we also have teams just using the devices and just using the device functionality. For example, the mobile application team sending a new target temperature of a room to the devices, or adjusting time schedules of the devices so that the device, for example, starts heating in the morning and stops heating in the evening in order to save energy. So a solution to all of these various challenges is or can be a digital twin. So and we understand by that we provide APIs for accessing the device data, but also to interact with the devices, to send commands or invoke actions, speaking in Web of Things. We have a digital twin can abstract from the protocols the devices are connected with. So we saw we have at least 2 different protocols devices are connected with. On the digital twin API, the protocol is basically irrelevant, does not matter how the devices are connected, but the data is still presented in the same way. Access control is handled by our digital twin. So granting access for the various user groups is managed by our twin. And we also enable higher order twins, for example, to control not only the devices, but also to control rooms or even complete apartments or even complete buildings for the landlords, for example. And the digital twin is kind of used, or it's used by not only one team, but it's used by different development teams. Some teams providing the devices and providing the digital twin of the devices, and other teams using the API of the digital twin. And so we see that digital twin as IoT middleware in our IoT platform as a center pillar, which many teams can interact with and can rely on. Coming to Eclipse Ditto, which is our preferred digital twin solution. So Eclipse Ditto, we think the first meetup in this community group was about Eclipse Ditto. Unfortunately, there's no recording about it, but we have some other recordings available on YouTube as well. So Ditto is such an IoT or digital twin middleware, and it connects the devices via device connectivity abstraction, and from the north side, then applications, IoT solutions, mobile applications or web applications can directly interact with the APIs provided by Eclipse Ditto to interact with the digital twins of the devices, so to send commands or to receive the last state of the device. And in this special case where the devices are mainly offline, the mobile applications or the applications would get the state from the digital twin, how the last reported state from the device would be available at the API of Ditto. In our case at Bionex, our device connectivity layer is AWS IoT Core, which we use as a LoRaWAN network server. So really short refresher or introduction about how Ditto does that, providing these APIs. So this is a typical JSON representation of a thing, so a rather minimalistic one. So a thing has a thing ID, which uniquely identifies the thing in Ditto. It links to a policy ID or to a policy. The policy contains the access control information about this thing. It consists of attributes, which can be seen as static metadata, which does not change over time. So a serial number of a device should never change over time. And normally also the building in where the device is mounted also does never change. And it contains of several features, and features typically contain sensor data provided by the devices, but also configuration of the device, which can be adjusted over the API. And what Ditto does with such a JSON, it automatically provides HTTP APIs for the complete thing, which you can interact with HTTP verbs with, but it also provides for each hierarchy level in this JSON, it provides an endpoint. So you can, for example, get the current temperature value by invoking this HTTP endpoint, and then you will just, as a result, get this current value. Ditto's Web of Thing integration, briefly shown, is now, in addition to the thing ID and the policy ID, we can add a definition to the thing, to our digital twin, and this can reference a Web of Things thing model. So in our case, we use it similar to this. We have some HTTP domain some publicly available models, and here we link a thing model JSON LD file, and that means this thing is defined by the following thing model. And what does that mean? Ditto brings some different integrations based on that definition. For example, when creating a new thing, a JSON skeleton is generated based on the defined properties of the thing model. For each thing which links to a thing model, Ditto can on the fly create a web of thing description and serve it as HTTP API using the specific accept header to fetch the thing description. And so it does that by using the model, but generating the complete forms as HTTP, HTTP binding. So for all of the properties, actions, and events defined in the model, Ditto will automatically generate the correct form entries. And now, very new since Ditto version 3.6, which we just released 2 weeks ago, Ditto will also use the thing model or it can be configured to validate thing modifications based on the thing model. So when you, for example, change a property to a data type which is not defined in the model, so you want to adjust a string to a Boolean, then Ditto will prevent this and will respond with an error message why this was not possible to do. And on that, I want to show an example. So what I just said, for example, if you want to adjust the serial number, which was a metadata before, so an attribute, if we want to adjust that to false, which is a JSON Boolean, but it is defined in the model as a string, Ditto will respond with that error message. So it will reject the API call with a bad request, HTTP status 400, and it will say that provided Ditto payload does not conform to the specified model. And it then says in more detail the serial attribute contained validation errors. And then we have an object of that could also contain several validation errors if, for example, modifying the complete thing at once. And here it would say, okay, in a JSON pointer notation, the serial we find type Boolean, but string was expected. So I really have to change that, for example, and use quotes around that false, then it would be a string, a JSON string. And why do we want to do that? And why do we also need Bionics want to do that? Yeah, programming errors happen. We have multiple teams injecting data into our digital twins, and we always want to be sure that the contract is met, which we build a lot of tooling on and rely for other things that this contract, which we defined as a web of things thing model, is always met by the thing or by the digital twin. And also for example, for action inputs, the validation is also very useful. So guiding third-party users or partners for the Twin API with helpful error messages in case they make errors when invoking an action, for example. So coming to the models part, yeah, I already talked about, we use Web of Things thing models a lot, and I also talked about that contract. So they are really important for us to have a model-based approach of defining first a model and then afterwards implementing the ingestion and filling the digital twin with data based on the defined model. And now how we use them in our thing models, we use inheritance, so using TM extends from the Web of Things specification, and we also use composition using TM submodel, applying a really object-oriented way of modeling our entities. So for example, this SRT, this thermostat, is a device, so this would extend a device model. and a device is aware of its identity. So our device model would extend an identity model which provides an identifier and also a location, for example, where the device is located. And coming to composition, a thermostat has a functionality regarding temperature control and child lock and battery usage. And these are then mapped in Ditto to features, so to the more dynamic part of the digital twin containing sensor data and configuration. But also a room can have a functionality regarding temperature control, because, for example, the mobile application would want to control the room and not every single device of the room. But the room does not have a child lock functionality and not a battery usage functionality. And occasionally, we also import single capabilities cross-model using the TM reference keyword of the standard. Yeah, so what we really do really object-oriented way of modeling our world. And as I told you, for example, this smart thermostat, this is a LoRa device. LoRa devices always contain a dev EUI. A LoRa device is a device. For us, devices always contain a serial number and a manufacturer. And the device is aware of its location. So in which building it's located, in which apartment, in which room, and when was it mounted. And they are identifiable. So which ID in our system do they have and which type of device is that? And we also have, for example, not only we have devices modeled via Web of Things thing models, but also, for example, a room. And a room would also be identifiable. It has an ID and a type, and it also contains links to an apartment ID and a building ID. And in that case, we also see here the composition. A room has a temperature control, and the smart thermostat also has a temperature control, but in addition to the temperature control, child lock, and battery. Yeah, so that class diagram can be broken down into Web of Things thing model and extensions and submodels. Now, how do we create models? Yeah, we just use our favorite IDE, and that in our case it's IntelliJ, to create new thing models. The first ones I created, and as kind of being already expert on the thing model format. And if you have, of course, more and more thing models, you can also use copy and paste from existing thing models to get quickly started with the stuff you want to model. We apply semantic versioning, so you can already see we use the version number in the thing mod in the file name, and also in the version model field of the thing model. We commit and push the thing models to a version control, so to a Git, and our CI/CD pipeline automatically publishes the thing models to a development website whenever we make changes to it. We create Git tags to release thing models or to release the complete model repository, the Git repository at once. And based on that Git tags or on the released thing models, we can deploy basically that also with our CI/CD pipeline to a QA website or to a productive website. And there, the released models are mutable. So once we create a version and publish it to QA and prod, we can never again change this version, but instead we would have to create a new semantic version, so either a bug fix version or a feature addition or breaking the version by increasing the major version number. Yeah, that's how we use and create models, and also we build quite some tooling around the models. So because Web of Thing models are really great, and we wanted and needed to invest tooling around them. Because still writing, enhancing thing models from hand is very hard. So the learning curve for newcomers, it's not easy. It's very steep learning curve, And also reading the thing models, we experienced that this is also not trivial to do. So there is some tooling needed in order to get all of the developers up to speed and to working with our thing models. For example, we created a tooling to generate open API definition files for complete Ditto things based on only the thing model and on the Ditto knowledge to which endpoints the thing model will map an HTTP endpoint speak and to which HTTP verbs this will translate. And during that step of generating this open API, we also ensure and make sure that the Web of Things thing model can be parsed correctly, so that it's valid JSON, that it's a valid thing model, and that the output is, or that all the required fields of the thing model are present, which we need for generating the open API. We integrated that tooling in our CI/CD so that we automatically generate this open API for merge requests or for pull requests. So whenever there are changes to the models, this tooling will automatically generate an open API definition. We'll publish it to our website, and from there we can use Swagger UI to parse the newly updated open API definition. And that's, for example, how this can look like. So in the example of the thermostat, so I created a simple example model. We have the complete thing, which we can get and which we can patch. We have all of the attributes as separate endpoints. As I briefly showed, Ditto will create separate, one endpoint for each JSON hierarchy and each JSON leaf. And if we look at the schema of the Swagger UI, we see the complete schema from in JSON schema, and also using the defined JSON schema restrictions from the model. So regular expressions defined as pattern or min-max values in the target temperature, for example. We also created a tooling about code generation. So we had challenges to keep our things consistent. Often we used, or manually written, updating the digital twin resulted in typos or in wrong data types. For example, we modeled a number, but someone put quotes around it, and then suddenly in the twin it was no longer a number but a JSON string. And these kind of errors happen often. So we created also some tooling to help our development teams with that. We mainly use Kotlin as a programming language. So we created a code generator for Kotlin data classes, also for complete Ditto things, for example, for this thermostat. And we also generate a Kotlin DSL to simplify it to build new instances of the things, including compiler check, for example, if we use wrong data types. We will see that shortly. And we provided that as a Maven plugin so that it can be in Java or a Kotlin project would be automatically executed during the build. It will fetch the thing model from the HTTP URL, download it, and then generate classes on the fly, writing it to a folder and adding it to the Maven project, compiling the generated sources. That's how this looks like, for example. So in the thermostat example, we generate something like this. It's a thermostat class. It contains certain blocks to build then the attributes and the features. And this is part of the Kotlin DSL. And we will also, for each feature, generate a class, a data class, and for its properties as well. And for feature actions, we will also generate the actions input and output to a subpackage. And on the right side, we see the Kotlin DSL. So this feels really like writing JSON. However, with the benefit that we can, that the compiler does type checks. So for example, here, when we create an update for the battery feature and want to set the voltage to a to a 3.8. And now we did the mistake of adding the quotes around it. The compiler will reject that change because we generated that voltage type as a double or as an optional double. And we provided strings, so we won't be able to compile this piece of code. And then what we get here is an instance of a thermostat, and we can just use the Jackson Java JSON serializer to generate JSON out of it. And our newest tool is about model migration. So we also, of course, want to involve things over time with new capabilities or thing models with new capabilities, with new properties. For example, we also do firmware updates for the devices, and then they learn new tricks over the time, which we have to also place into the model, of course, to use those new APIs, for example. So we provide a tooling also to migrate, similar to a database migration, things from one reference thing model version to another one, and we patch the delta into the things by in this tooling created. So this is also an example of this tooling that's also included in our CI/CD pipeline. So whenever we created a new version and merged it, we can run this tooling, can say, okay, for the thermostat, we now have model version 1.5. And then we get a suggestion of a migration payload, which is automatically calculated by our tooling, basically applying a diff, which new properties were added. In this example, for example, here, an attribute would have been added. We can define its default value, and a new feature would have been added, a party mode, and we could also provide a default value here. And then we could, for all available twins in our Ditto installation, define a filter to which we want to apply this patch. If we now would authenticate with a bearer token of OAuth, we would then here get a live count, how many things would be affected by this patch or by this migration. And then we can submit, and that form will then create a new pipeline in our CI/CD and start the migration of all of the thousands, 10,000, 100,000 things to a new model version. And what is also part of this tooling, that we have a diff tool a diff tool where we can say, okay, please show me the diff. What changed between version 1.4 and 1.5? And then we see, similar to a diff in version control or a patch, we see what changed basically. Here, version numbers changed of the linked thing model. And for example, here an offset property was added to this submodel, submodel version. So wrapping it up, we mainly use Web of Things thing models. Ditto, however, and Ditto can now, since the latest version, ensure that all of the changes we do to the digital twins are always conforming to the Web of Things thing model or adhere to the model. Ditto can generate thing descriptions to be prepared for future integrations, for API descriptions for partners, for example. So we are still 100% or still fully complying to the thing description, but we can just generate that. And at Bionics, we invest a lot in tooling around the thing models and also in the Ditto integration of Web of Things. For example, this validation we just recently added to Ditto, which was quite an invest, but we really see a lot of value in making sure that the model is always as it was, or the things always adhere to the thing model. It's really a great thing to have. And for example, regarding the Open API generation and also regarding Kotlin code generator, we aim to make those generic toolings around Ditto and thing models open source soon. So as a sub project of the Eclipse Ditto repositories, we will open source these toolings so that they can also be used by any other Ditto user wanting to or needing to use the Thing model integration. So thanks a lot for attending and your interest, I would say. And now I'm happy to answer questions if you have any.